you. So this is fifth question from free response question series 2024. Let's see what's there in the question. Question says that at time t equals 0, the block A slides along the horizontal surface towards block B, which is initially at rest as shown in the figure. So this block is at rest and this block is going towards it. The masses of the blocks A and B are 6 kgs and 2 kg respectively. The blocks collide elastically at t equals to 1 second, and as a result the magnitude of the change in kinetic energy of block B. So this block has a change in kinetic energy, we can write K, is 9 joules. All frictional forces are negligible. Determine speed of block B immediately after the collision. So there is a change in the kinetic energy of 9 joules. So earlier it was 0, so kinetic energy is also 0 because the velocity is 0. So we will say that change in the kinetic energy for B is equals to half mv square, which is now 9, so equals to half. Mass is 2 kgs and velocity square. So 2 and 2 goes off and v is equals to 3 meter per second. So this is how we have to solve the first part. Let's see what's there in the second. In the second it says, let's little zoom out so you could see. Okay, the graph shows the figure 2 represents the position x, okay, of block A, block B, and center of the mass of the two block system as function of t between t0 to 1 second. Okay, so what it says is like this was the block and this was the smaller block. This was of 6 kgs, this was of 2 kgs, and this was not moving, this was static, and this was moving. And after the collision there must be some movement, and we have already calculated that it was 3 meter per second speed. And okay, so now they have given us a diagram, a graph. On the graph, draw and label 3 lines to represent position of block A, B and the center of the mass as a function between from 1 to 2 seconds. Each line should be distinctly labeled. So here they have shown that at t equals to 0, because this is time t and this is x m, because it is written little above, you can see xm, so I have written again. So at time t equals to 0, this object was at 2 meters, like 2 meters apart, and this has now then started. After there at 1 second they just collided, and after the collision now we know that this block B would be moving with 3 meter per second. So from here in 1 second it will move 3 meters. So from first second to second second it will move 3 meters. So 1 2 3. Here from 2 to it will reach at 5th. So this will be the one line that need to be marked. So this line is for B. Now we will say that what will be the value for A. Now to calculate A, we know that the change in the kinetic energy here must be equal to the change in kinetic energy here. Now this is like V, and this was 0, it was velocity V. Here with initially it was coming with V and 0, so change of this is So now from this diagram, yes, from this diagram you see that this block A, in 1 second, this block has covered 2 meters. So the speed is 2 meters per second. So if this is 2 meters and this was 0, so we can now calculate the total energy. So total energy will be half, mass was 6 into V square, 2 into 2. So this will cut off and it becomes 12 joules. So the initial energy was 12 joules. Out of which 12 joules, 9 joules were given to the smaller part. So we are left with only 3 joules for the bigger part. So half bigger part into the velocity square equals to 3 joules. Okay, like 12, then 12 minus 9, we are left with 3 joules for the bigger part. So 2, 3, and with 3 and 3 goes off, so V equals to 1 meter per second. So now we know that after the collision this velocity will be equals to 1 meter per second. Now from 1 to 2, this object from 2 meters it will reach to 3 meters. So now we can draw another, using another color we can draw like this. So this will move like this. And then it has also asked to draw the center of the mass of the two blocks. See, center of the mass will never change. So the same slope will get extended. So there wouldn't be any change from this. Now let's see what's there in the C part. The C part says, consider if in the original scenario, instead of colliding elastically, the block collides and stuck together. Describe how the line drawn for the center of mass B would change, if at all. See, the basic reason is that center of mass will not change because the center of mass will remain same, like the momentum remains same. So if they stick together or they move ahead, the center of mass will be there. So center of mass will always go with this same slope, and we can calculate also. Like for that, we know that this is how much? 1. No. What was the speed with which it was coming towards it? It was, just wait. The speed was 2 meters. And then it was 0. Okay, 6 and 2. So this was 6 and this was 2. So the total, yes, total we know that 12 joules was the energy. So this 12 joule energy will be like half total mass, 6 plus 2 is 8 into V square. So it would be 2 4s are 8, 4, 3 is a 12. So V will be root 3, which will be 1.76. So if you will try to locate it here, like this would be like here. So this point will be 1.7 from 2. Okay, this length would be 1.7. If you will, like in some experimentation, they can ask you what would be the intercept. Then you can use this concept here. So this is how we have to solve, and hope you got all the answers from this. It was a very small question. So the first part has been clearly done, and then the second part, B and C. So hope you liked the video and you got the concept right. Thank you for watching this video. If you still have some doubt, you put it into the comment section, or if you need some one-on-one classes, just contact me. Thank you.